Okay, welcome to video 6.6. Here we're going to talk about compounded interest. So in history, banks collected interest at the end of each year on the original amount either borrowed or invested, and that was the principal. This type of interest was called simple interest. As time went on, banks realized that there was another way to compute interest and make even more money. They called this type of interest compounded interest. So to compute the compounded interest, banks calculated the interest for the first period and then add it to the total, then calculate the interest on the new total for the next period and so on. So since we are calculating a rate percent and it's growing to earn interest, the compound interest formula models the exponential growth equation. So we have the y equals ab to the x power, just using different letters to represent banking terms. So really it's no different than just using the y equals ab to the x, and it's an exponential growth, so we're going to replace it with 1 plus the rate. Now we're just replacing them with different pieces that represent the banking world. So a of t is the amount earned or owed after t years. P is just your principal amount borrowed or invested, and that's your starting, your A number, your initial number. So it's really no different. They're just representing it with a different variable. R is still your rate, and you have to convert that to a decimal. And then T is, in this case, time in years usually. Okay, so let's look at the first example. So you have Sarah who invested $800 in a savings account, and that was paid 4.2% interest compounded annually. How much money to the nearest cent was in the account after 4 years if the money was left untouched? Okay, so again, we can think of this as an exponential growth. We can use y equals ab to the x, but we can also use this a of t formula. So a of t, which is just going to be the amount earned in this case since she is in a savings account. P is your principal, so what did she have at the start? That was the 800, just like the A value, the initial amount. And then the rate is the 1 plus, can't put 4.2% into my equation here, so we have to convert that by moving the decimal place 2 places to the left, so we get 0.042 and we could put it as t power, but then remember that we're going to change that because we need to find how much for 4 years. So now I can replace that with 4. Then it's just a job for our calculator. We put it in the calculator and we get this decimal. But remember that it's money, and it even said in the directions that we needed to round to the nearest penny, nearest cent. So my final answer here is the $943.11. So again, not much different from what we were doing in the previous. We're just using new terms. It's still an exponential growth. You can use y equals ab to the x power and just replace them with these terms. It's still an exponential growth in this case since it's a savings account. So we're 1 plus the rate since it's going to go up. And just remember that you have to convert these percents into decimals so that we can put them in our equations. Okay, that's it for the new information for this one. And just remember to always read carefully. If they said how much money to the nearest whole dollar, we would have had to round differently. And if they don't give us anything, then we just say pennies because that's what money is. Okay, have a good night.